state space representation. So this state space representation offers a powerful tool to handle polynomial with higher order, namely with n greater than 3 and so forth. And it also provide a reduction method that we can use to simplify the polynomial of higher order ODE. And when we make use this state space representation, we will convert the ODE into matrix form, where this matrix offer more flexible or more freedom in terms of analyzing, in terms of design a particular scheme of control technique. So if we can understand well on how to determine or to express this state space representation from an ODE, then we can take benefit where this state space representation can offer us in dealing with control design and also the analysis of a dynamic system. So in terms of concept, we have three important terminologies. Okay, the first one is state variables. So the state variables basically the transformation variable that we use to describe motion variable come from the equation of motion or a certain ODE. And then we have a state vector. So state vector is a matrix that simplify or that contain state variable, be it state variable in derivative or non-derivative. And then we have state space. There's definition of state space, which basically describe the condition of the matrix size of the equation. So normally the expression of state space representation are given or are illustrated in two important expression. The first one is equation 2.14 and the second one is equation 2.15. So the first equation is known as state space equation. Okay, so this is the state space equation. Okay, so the state space equation tell us the behavior of the system properties. More or less, we tell us the system properties, not the behavior, but tell us the component which the system inherent or has. And clearly in this form we can see the properties of the system is given or is defined in a form of matrix. In this case, matrix A, and then we have another matrix which is matrix B. This matrix B is basically the constant or the parameter that associated with the input variable or input function, right? And then moving on, we have another set of equation which is known as output equation. So the output equation is an equation that depends on the state space, because as you can see here, it has the state vector of x. So state vector of x can be related can be related to equation 2.14, and while this C matrix is the constant or the matrix that um, tell us or provide us information about the uh, behavior of the output, and it pretty much depends on the equation 2.14.